we will move on to John Norby, who's the Chief Technology Officer of Sound Sensing. And John will talk about something quite interesting, how to perfectly roast coffee using TinyML sound sensing. So John?
Hi, thank you, Theo. This project was done by Sound Sensing for Rust. Rust is a Norwegian company producing machines for roasting coffee. Their S100 sample roaster shown here is the most modern sample roaster on the market and has won several design awards. The sample roaster is a type of coffee roaster that's used for sampling and testing coffee. Professionals in the coffee industry do continuously in order to test the coffee and give you great coffee. Sound Sensing is a leading provider of sensor solutions that combine audio and machine learning. Our technology is a combination of machine learning models, hardware, and a cloud-based data platform. And from this technology package, we build solutions for noise monitoring, for construction, office, and industrial use, as well as condition monitoring of technical equipment and processes that we'll be talking about today. And we are experts in using sound to understand the world. And it turns out also for coffee, sound is very important. So coffee roasting is the process of taking green, raw coffee beans and heating them up over time to develop the proper coffee aroma. After roasting the beans, they can be ground and used to make coffee. And the key to a good roast is, like any kind of baking type process, to stop the process at the right time. And the method used by the very best professional roasters is actually to listen for the first crack. The first crack is when water in the beans turn to steam and the beans pop open like a popcorn, making an audible sound. And this is done manually today by many professional roasters. However, it requires constant attention to the process over a 3-minute period, which makes it quite tedious to do. And different operators might also mark the first crack time a little bit differently in the roasting process. With Sound Sensing, we can automate this machine listening. So for Rust, we developed an on-edge solution, TinyML, running on a board inside the machine. It's using a MEMS microphone to listen to the sound and an ST microcontroller to do the processing with Sound Sensing firmware. We trained a sound event detection neural network to recognize each crack of the coffee bean. We used TensorFlow to train and converted it to run on the microcontroller using ST's XQ AI. Let's see how it looks in practice. So the operator starts the automated rotary processing by adding beans. After around 5 minutes, the beans start cracking. Here we hear a couple of cracks. Cracking is automatically detected, shown on the screen, and logged over time at the bottom here. And after a preset time from the detected first crack start, the machine automatically stops the roasting process, and the beans are ready. And the benefits of having this fully automated roasting process is that the operator can do other things while the machine is running. For example, you can operate multiple machines at the same time or do other parts of the sampling process. And this improves also the consistency between operators, different operators at different points in time, and it works well regardless of the operator's skill level. So, and this feature, acoustic detection of first crack, is the first in the world shipping on Rust coffee roasters since 2020, using the TinyML solution developed by Sound Sensing. And of course, this is only one small example of what you can do with sound, machine learning, and TinyML. So if you have a sensoring or monitoring problem that can be approached with sound, get in touch with us at Sound Sensing. Thank you.
Many thanks, John. I don't see any questions in the chat. I think there are 2 questions that are directed to Moshe. So Moshe, if you can, please use the Q&A box to answer the question. And John, there is a question for you. There's actually 2 questions for you, so you can follow up in the chat and answer them.
Actually, Theo, I have one question. I was wondering about the data sets, like what data sets you use, because I assume different kind of coffee make different kind of noise. So like,
yes, for sure. And the profile that you use as well, how intensely you roast the coffee. But since we Rust makes the machines, we have a lot of customers that could test this with us, and we collected and annotated a lot of data in that process.
I wonder how big was your data set? How many like negative and positive you had in your data set to be able to
we actually, to make the minimal viable solution, it was not many. It was around 30 roasting processes, and maybe on an average 30 events per roast, which brings up to maybe around 1,000 events possible. And a lot of noise.
Okay, yeah, thank you.
I was going to ask, my question was going to be about cold brew coffee, if you have tried that as well, but I don't know if the sound has an impact on cold brew.
Well, this is only in the roasting process, and actually I'm not enough of a coffee expert to know if you roast differently for cold or not cold, or if you don't roast at all. I don't know.
Yeah, that's true. Thank you, John. I would like to acknowledge again our sponsors. The sponsors are the ones that actually made having a free registration for everybody possible, starting by Newton.ai, who is innovating into the automated TinyML domain, who's also our premier sponsor. Next, we have the executive sponsors. We have ARM, which, as you know, builds from both the software and the hardware foundations for TinyML. We have Edge Impulse, who is advocating strongly, as you all know, for TinyML available to all of the developers. And of course, Qualcomm, who is working as, among other perception, reasoning, and action, and edge and cloud devices in various sectors, such as the Internet of Things, automotive, and mobile applications. And Sentient, who is moving artificial intelligence from the cloud to the edge, which, as you have seen today, it's quite now the trend nowadays. Next, we have our platinum sponsors, Infineon, part of your life, part of tomorrow. We have seen a few of their projects that they work today. We have Reality AI, who is working also in pre-building, pre-built edge AI sensing modules and tools. Next, we have our gold sponsors. Latent AI is the first one who works on adaptive AI for the intelligent edge. Then we have SensiML, which works on building smart IoT sensor devices from various data. And last but not least, our silver sponsors, EMSA from Israel, Greenwaves, HOTC, Magimop, Quixo, Seed, Studio, and of course, ST Microelectronics. I would like to thank everybody that stuck around until now, and I hope to see everybody tomorrow at 4 o'clock Central European Time